Welcome back to Genetics in the Paddock. I'm your host, Emily Johnston, and I'll be taking you along on my journey to learn about all things genetics in extensive livestock. Livestock genetics has always been a topic that's interested me, and now working in the genetic space, it's fascinated me even more with just how powerful of a tool it can be. And I'm surrounded by so many knowledgeable people who are so willing to share their insight, so I thought, why not capture these conversations on a podcast that we can all learn from? In this episode, I spoke with Tom Granleese, a quantitative genetics research officer at New South Wales DPI. He gives a really interesting introduction into female reproductive technologies and some considerations when opting to use these technologies for genetic gain. So you'll want to stick around for this one. And with that, let's get into it. So thanks so much, Tom, for coming onto the podcast today. I know we've spoken about actually recording this probably 5 or so times, so it's nice to have you in the hot seat today.
Yeah, thanks, Emily, and it's great to be here. We actually are in the paddock, and the cattle are calving at the moment, and we might hear them in the background.
Yeah, we'll hear some interesting noises from the maternity ward.
Yeah.
So, Tom, for those who haven't known you, I suppose we'll just jump straight into it. So can you tell me just a bit about yourself? Like, what's your current role at the moment, and what sort of industries are you working with?
Yeah, so I'm based here at the Grafton Research Station, and I have been with the department for 3 years now. Started in the first week of COVID lockdown 2020. And yeah, I'm working in cattle, sheep and goat research in quantitative genetics. And previously I was at the University in New England in Armidale.
Nice. So you started at the start of COVID. I feel like those years don't even count. It feels like it was such a long time ago now.
Yeah, what a weird time, wasn't it? So...
Interesting time to start, definitely. So were you able to do most of your role at the start of COVID lockdown, or has it changed a bit since we've come out?
Yeah, it's changed a little bit. I mean, when your first week is in lockdown, you can't travel to meet anyone, and you're doing everything online. So it was nice to come out of that lockdown and actually meet colleagues in person, and we're along and flying now, so we've got some wonderful people in the department that I love working with.
That's awesome. It's good to have a nice workplace and somewhere that you enjoy going as well. That's good. So how did this start for you? How did you get into genetics? Where did this all start for Tom? I'm curious to hear a bit of your background.
Yeah, so it's a bit of a funny story how it all started. So I grew up in a little town called Temora, southwest New South Wales, and lived on a sheep or a mixed farming property. So I've always grown up with agriculture, loved it, loved my sheep. But I guess where the love for genetics started can come down to when I was 10. During the holidays, the spring holidays, Temora show was a big deal, and I went and I entered the Grand Glutton Eating Contest, and I eviscerated the entire field, including adults, and got my photo on the front page. And my auntie told me she's never been so embarrassed in her life. So after that, my uncle and grandfather had a dairy in Grafton. So from then on, my mum and dad would put me on a bus or on the train by myself from the age of 11, and I came up and worked on their dairy in Grafton every school holidays. So it's a bit of a long story, but they had a stud, and so they used to have registration pages of all their stud Holstein cows, and on the back of the page they had breeding values and visual classification scores, and my brain started to connect the higher scoring cows to pedigrees that were listed on each registration sheet, and that's, I guess, was the triggering moment of learning to love genetics.
That's cool. I really like that you have a moment in time where you can actually pinpoint, yep, this is where it all started. So once you, I suppose, understood that was where you wanted to go, did you do an ag degree and then a PhD? How did it kind of go from the 10-year-old loving genetics to where you are now?
So I did an undergraduate degree in animal science at Melbourne University, and I actually sort of moved away a little bit from genetics. I did an honours project in IVF in cattle, and I actually, when I finished my undergraduate, I went up to Rockhampton and managed an IVF and cloning lab for cattle. But then the live export ban and all the floods in 2011 hit, and I lost my job. And went back to uni to do a PhD in Armidale.
I've spoken to a few people from the animal genetics and breeding unit out at Armidale. So was your PhD with them or through them, or is that kind of...
Yeah, so I actually sat in the AgBoo building, but my PhD was through University of New England. So I was extremely fortunate to have three fantastic supervisors, Julius Vanderwerf, Andrew Swan and Sam Clark. Anyone who knows genetics would understand that I was a very lucky student.
Absolutely. No, that sounds like a really great introduction to genetics, and it sounds like you've had a pretty great career since then. I mean, you had a really great foot in the door and it probably has continued since. So what are some of the highlights from your career at the moment, or is there any sort of piece of research that you've completed that you've just been like, wow, that was so cool, I'm so glad I got to work on that?
I find myself really fortunate. I guess when I think about people I get to work with, the genetics community, I see family, and so every day that I get to collaborate with those guys, I feel really fortunate. So some highlights I think from my very short career so far would be we've just finished the UNE Merino Link DNA stimulation project, where we were able to work with a bunch of really significant merino stud breeders and commercial breeders, and we increased the rate of genetic gain by 134%. So that was really good and cool, and bringing science to implementation. We had a great team that helped develop the flock profile genomic testing tool for merinos. And I think, in a sense, just finishing the PhD was a huge achievement for me. I really struggled at the start, like probably most students, and sort of battled through it, and towards the end everything sort of started to click. So that was really fun, and that sort of brought together a couple of my passions, which is breeding program design, reproductive technologies, genomic selection.
So you mentioned, I mean, there's a fair bit in that you've done and are really interested in, which is really cool, and I'd love to sit down with you and talk about all of those individual components, but unfortunately we're a bit time short today. But you mentioned you've done some work on some female reproductive technologies, and I actually had a look at one of your papers recently that mentioned that. So can you just talk a little bit more about some of the research you've done in that area?
Yeah, so that was the title of the thesis was looking at the synergies that exist between female reproductive technologies and genomic selection. So a lot of the thesis focused on looking at how best we could use technologies such as multiple ovulation and embryo transfer, or juvenile IVF. So basically we're turning cows or ewes into sows so they can have lots of progeny. And then we used that and mixed the tool of optimal contribution selection. So that's a fancy way of saying maximising genetic improvement while maintaining genetic diversity. So we mushed that all up in together and looked at how we could blend all those three tools and get a really, sustainable breeding program.
So with these technologies, you mentioned that they help to increase the rate of genetic gain, but what sort of role exactly do they play in that, and how does that increase genetic gain?
Yeah, so basically to increase genetic gain, we need to pick the best animals, and if the best animals can have lots of offspring or progeny, we can increase the rate of genetic gain a lot faster. So in animal breeding, the easiest way to do that is by using males, because males can be used across a lot of females. Females, unfortunately, due to reproductive capacity, can only have one calf or up to 2 or 3 lambs or kids. So a way to increase the selection pressure or the selection intensity on the female side is to use these reproductive technologies. So we use less of the better females, so less females, but the better ones, to increase the rate of genetic gain. But there's a catch to it all, and that's the potential to increase inbreeding.
Yeah, I was just going to ask, it sounds really great, but is there a catch? And what are some of the disadvantages that can come with that, and why is inbreeding a disadvantage? Like, how does that kind of fit into it?
That's a great question. So we can get caught if we just do selection of the best animals. Quite often we have best families. So if we just do the selection of best families, we might select all members of a family who are elite. And so that's a risk, because in the future we've got a lot of the same genes in the female base, and we run into co-ancestry or inbreeding issues. So we want to avoid high rates of inbreeding, because inbreeding, explained in other ways, the fixation of genes. And if we don't have variation in our genetics, it means we can't make progress in whatever trait, production or reproductive or health trait that we're trying to improve.
Cool. So, yeah, it sounds like there's clear advantages and disadvantages for using the female reproductive technologies. And I suppose it probably is up to the breeder or the producer to decide that for themselves and decide whether that's the path they want to go down. But are there any sort of financial costs associated with these technologies, and how would they impact breeders or producers? And another question to add on to that is, what factors determine whether the investment is good or it's going to benefit them?
What a loaded question.
I know, 2 in 1.
So there's a few different parts. I guess there's a few different components to that question. So yes, it is expensive. It is a significant investment to invest in female reproductive technologies. So broadly speaking, it will cost about $1,000 an animal from an embryo transfer program or a juvenile IVF program, whereas it'll cost between $70 to $150 for an AI bred progeny. So is there a financial benefit to the investment? Well, it's very dependent on the breeder's philosophy on the investment. So we can use these technologies to expand new breeds. So if there's a new breed entering a country, so there's a lot of embryo transfer used with Wagyu, there's a lot of embryo transfer used in the Dorper breed. Once you're at expansion, and whether that pays or not, or whether that's an investment into the future or a loss that the breeder is willing to make to establish a breeding population, a breeder may then say, well, I have a female who I've sold a bull or a ram from every year, and it's the top one. So if I can flush that particular female, I know I'll get resulting progeny, I know that I will get a return on that investment. So the other part to, I think, the paper that you read, we actually factored the cost into the cost of selection, where just purely from a genetic gain, so we know that reproductive technologies can accelerate rates of genetic gain, and we wanted to factor in, before we factored in cost, the program, the optimal contribution wanted to use a lot of the reproductive technologies, but in reality, breeders don't have bottomless pits of money, so we wanted to factor in the cost, and it's very hard to factor in like a phenotype sort of cost. So one thing we could do was looking at the benefit of genetic gain and how much of the benefit a bull or a ram buyer was willing to pay of that benefit. And what we found was the best and most economical benefit is still made through genomic testing and the use of artificial insemination, because the cost of reproductive technologies costs a lot. The one cool thing that we found in it was that where we use small amounts of embryo transfer doesn't really impact the rate of genetic gain directly, but what it can do is, it's a bit like snooker where you play 2 shots ahead. It breeds, we can breed a future sire or a future outlier that then accelerates the rate of genetic gain in the following generation. So that was one nice thing that we did find.
Yeah, right. That sounds really interesting. You guys did a whole lot of work on that paper, and it sounds like you factored in a lot of really important considerations that breeders and producers would have.
Yeah, so it was a really fun paper. It was quite technical, and those papers were of using optimal contribution is the same philosophies that mate prediction programs such as MateCell use. And I was just so lucky that I needed a bit of technical help, and Brian Kinghorn, who is the inventor of MateCell, actually got to help me on that. So that was, I guess, a real highlight.
Yeah, awesome. That sounds cool to have Brian work on it with you, considering he invented it. I feel like that's absolutely a wow moment and a career highlight too.
Yeah, and anyone who knows Brian would understand that it's a thrill to work. He's such a positive guy and a genius, really.
Yeah, awesome. No, that's cool that you got to work with him on it. And I love that you have this such fond memory of working on that paper and, yeah, all of that with him. I'm curious as well. So we spoke a bit about genomic selection and we've touched on that in a couple of different episodes. But what are some of the potential interactions and benefits that might exist when combining these technologies with genomic selection in breeding programs?
Yeah, so from a practical point of view for breeders, genomic selection or genomic testing gives the most benefit for traits and individuals that haven't been measured yet for a trait. So that's either really young animals or for traits that are really hard to measure, like eating quality, or later in life, like reproduction on females, or even in a dairy sense, you can't measure milk on a bull, right? Because it's a bull. So that's been the real game changer with genomic testing, is that we're able to get more accurate breeding values on younger animals. So if we can go to the old breeders equation, if we can decrease generation interval, we can increase genetic gain if we can make more accurate selection earlier. So that's where, like juvenile IVF, where we're getting making embryos out of 1 month old animals, or embryo transfer on an animal that hasn't had any progeny yet.
Yeah, okay. So we spoke a bit about the financial cost of this as well. So how do you see seed stock breeders recouping the cost of using these technologies, and who ultimately benefits from the progeny that's been genetically improved?
Yeah, so this is a real area of passion of Rob Banks, who recently retired. He was the director of AGBU, and it's his strong belief, and mine as well, that commercial buyers will never pay the full amount of genetic improvement that a breeder makes. So if I was to be giving farmers advice or breeders advice, I'd be saying you need to be really strategic about using the reproductive technologies, knowing that AI is still the most effective way of making genetic gain in terms of from an economic perspective, and the use of genomic selection. So using ram lambs or yearling bulls is a really good way of doing that. And so to get to the question of who benefits the most, well, the commercial buyer of the bulls benefits the most, because up until very recently, where bull prices and ram prices have been really high, the commercial buyers have not been paying their full whack on genetic improvement, and we don't see studs who are achieving higher rates of genetic gain getting premiums over studs who are getting or have slower amounts of genetic gain. So I would say to the studs, be very selective on who you do embryo transfer or IVF on. There needs to be, if we're talking economics, there needs to be some sort of payback that you can see. So whether it is that you breed yourself a future stud sire from the program, or that that you get a lot of marketable rams and bulls from that particular program and mating, it's from an economic point of view, it's hard to justify from a genetic gain point of view. So the one caveat on all of that is, for people who are breeding their own bulls and their own rams, where they have a commercial herd to capture all that genetic gain, then it's pretty much a case of go your hardest, because your commercial herd pays you back. They're the multipliers of your hard work of genetic gain. So if you're capturing all your genetic gain, or in another way you're paying for that genetic gain. So if you're breeding your own rams and your own bulls commercially, and you've got that big commercial herd to multiply out, then the investment of reproductive technologies does pay, because you're accelerating your rate of genetic gain, and you're capturing or you're paying for it all.
So it sounds like there's a lot of different things to consider, which is probably a lot for a producer trying to make all these decisions along with all the other ones they've got to make in their production. So how do you think breeders can best strike a balance between optimising genetic gain, managing inbreeding, and considering the financial implications of using these technologies?
Yeah, so there's as I mentioned before, there's a really cool tool called MateCell available to breeders, and that can be for sheep producers. You can get it free through your sheep genetics membership. I'm not quite sure about the cattle, but it's a wonderful tool to strike the balance of maximising genetic gain but still maintaining genetic diversity. And sometimes breeders, before they use it, sort of get a little bit worried that they feel like the decisions are getting taken out of their hands from a phenotypic point of view. You still get to class all your females in based on phenotype. You can still pick all your bull candidates based on breeding values and phenotype. It's just an incredible tool that can look at millions of different mating possibilities across your whole herd in minutes. And what I've found is once people start using it, they understand that I've got better control of my destiny because it's making these really complex decisions, but I'm still in charge of the phenotype direction I want to take my livestock. Optimal contribution selection is really cool in that instead of picking the best females from all the same family, they pick the best females from each family line, and that's a really useful way to help minimise co-ancestry.
So I've spoken a bit about the seed stock producer, but I'm curious as well about from the commercial perspective. So if you're a commercial producer, should you be using AI? And to follow up with that, should you be paying more for these genetically improved animals if seed stock producers are using these technologies?
Yeah, so from a sheep point of view, it's very hard to make the economics of commercial AI of sheep because it costs about, if you're buying semen, it costs about $75 plus labour to get a live lamb on the ground, whereas a ram might last for 2.5 matings on average, and they're mating 80 lambs and 120% lambing. You're getting about 240 lambs in its life, and that's coming at a cost. If you're paying about $3,000, it's about $12 per live lamb. So it's a big difference. From a cattle perspective, bulls are way worse than rams because bulls can mate about up to 50 females, and they can and cows only have one calf, whereas sheep and goats, they have 2, maybe even 3 lambs or kids. So for bulls reproductively, you don't get as big a bang for your buck than compared to sheep or goats because they can only mate about 50 cows in a season, and cows only have 1 female versus the ewes and the does that might have 1, 2, 3 lambs or kids. In saying that, if you're paying, say, on average $10,000 for a bull, and they last for 3 matings, which is about the average, you're getting about 140 live calves. So the average cost for progeny there is about $75. Now, if you're buying semen for $50 and you're getting a 60% conception, it works out to be about $150 a calf. So do the genetic gain benefits outweigh that extra cost per calf? Maybe, if you've got a value proposition bull, or you're coming from a really low base, or you've got a bit of a niche market that you can move into, like high-grade marbling. And then there's the other benefits that you also need to factor in, like tighter calving or lambing windows, earlier turn-off times. The cows have extra time to go back in calf, or the ewes have extra time to go in lamb or recover. It's hard to make the numbers work, but you can. But it's certainly something that requires a bit of thought.
Okay, I feel like you've given us a lot of things that are food for thought in this episode, which is really cool. It's nice to have something to take away and think about because, there's some really cool technologies here that are available for use, and I think that's important to consider. So to wrap this up, I guess we've spoken about a lot this episode, but what do you think the key message is that producers should take away from everything that we've said today? If you just have one small ticket, like piece of information, what would it be?
So the key message for seed stock producers are it's very hard to justify reproductive technologies costs unless you're getting some sort of benefit paid back to you from either your clients, and it's definitely worth it for if you're breeding your own bulls or rams and you've got a big commercial flock or herd to multiply those benefits over. But the use of genomic testing and the use of artificial insemination is certainly the most cost-effective way to continue your genetic improvement. From a commercial point of view, my key message is use a stud that is getting good genetic gain in your key breeding objective traits, because you will go in the same direction as your seed stock herd. So if you go to a stud that's making more genetic gain in your key profit driving traits, that is of benefit to you.
Awesome. No, thanks so much for that, Tom. I feel like you've summarised that perfectly. It's been a great episode, and I've personally learnt so much, and I'm sure everyone else listening will also feel the same and have a lot more to think about, which is always good when you're in the world of trying to improve. So, yeah.
Oh, well, thanks for being a great host, Emily. You're always welcome to come up to Grafton and listen to our noisy cows in the background, and yeah, hopefully we can do another one.
No worries, Tom. I'm sure I'll book you in for season 2. Thanks so much for today.
Can't wait.
Thanks, Tom. Thank you for tuning into this episode of Genetics in the Paddock with Emily, a podcast produced by the extensive livestock genetics team within New South Wales DPI. We hope you've enjoyed this deep dive into the world of genetics and its impact on livestock production. If you found this episode informative and engaging, please consider subscribing to the podcast and leaving a review. Your feedback is essential in helping me to continue to bring you valuable content on livestock genetics. If you have any questions, comments, or suggestions for future topics or guests, please don't hesitate to reach out to me on social media or through email. We love hearing from our listeners and are always eager to explore the subjects that matter most to you.